Is the screen visible?
Yes, it's visible.
Yeah, so just to confirm, in class you've studied, I believe, ROC, AUC under ROC, and then some feature engineering for this thing, linear regression, right?
Yes, ROC is the word, but this is week 9 material, right?
Yeah, your voice is breaking a lot. Can you maybe, rejoin the meeting?
Is it?
No, still breaking. Yeah, maybe you can type it in the chat.
I can't type in the chat actually.
No, I'm receiving a lot of static. Okay, anyways, maybe we'll start with this. So the idea is to use a confusion matrix, then compute the ROC, then maybe find out which threshold is the best for that, and maybe visualize the confusion matrix as well. Visualize the CF, we have ROC, UC, and then some feature engineering for linear regression. So let us use a data set. Is this? It's not CSV. Just a minute. Okay. So can you access these XLS files, then read it into pandas using Excel, or you can first convert them to a CSV and then read it into Excel, okay? I don't think it will read it raw. Is that clear? Meanwhile, I'll try to get up the CSV files. So the first task is to will train an sklearn regressor, logistic regressor. We'll make some predictions. We'll compute the confusion matrix using sklearn. Then we'll try to do it ourselves and see if it matches. And then we'll visualize the confusion matrix. Were you able to access these files? Anyone?
Yes, downloaded.
Okay.
Uploaded to the lab. But the screen is blank currently.
The screen is.
Oh, I think only this screen is being transmitted or something. If you switch to something else, then it shows a blank space.
So does it blank out sometimes?
Yeah, it white.
Okay. Okay. Yeah. Just. Now is it okay?
Yeah, it's visible. Yeah.
Okay. Okay. So let's start. We have the path. Let's import the data set pd dot read underscore csv. Give it the path. Header is 0. Yeah. So we have this. Now to build a logistic regression, that is quite simple using sklearn. So what we do is we just create a class, an object first. Let's actually see what does it offer us. In logistic regression, we have the options for penalty. That is when you go for maximum likelihood estimate. What do you want to minimize? and tolerance C, most of regularization, state fit, intercept, scaling, class, weight. How many do we have? So let us say we have df dot coupon dot value underscore counts 60/40. So not a major class imbalance. So we can set random this, and we all obviously have solver as well. So we don't need to interfere with any of the parameters. So let us just train it this way. We have model dot fit. In fact, let's maybe create a train test split first. So let us shuffle the data. So df is equal to df dot sample, and we'll say use 100% of the fraction. You'll just shuffle it, okay? And random state is, let us say, 0. So we have a shuffle data set. Yeah, shuffle data set. So reset index. Hmm. Now we can just take maybe 80/20 split. So we'll have df x underscore train, x underscore test, y underscore train, and y underscore test. So how do we do that? We don't want the coupon column in the training data. So we'll say df dot drop coupon, and x's is 1. Similarly for that one as well. Here we want to take the first 80%. So maybe create an index. Split index is equal to integer 80% of length of the df. So we want everything up to the split index, and in this case, everything after the split index. Okay. And in this case, we only want the coupon column. So we'll say df dot coupon and ILOC everything up to the split index. And in this case, df dot coupon everything after the split index. Now, when we run this, these lines will return either data frames. For example, this line will be a data frame. These lines will return series. So maybe we can convert them to NumPy up front so that they are just these values. I think we don't even need the customer data. I mean, it's just the customer ID, I believe. In fact, mm, yeah, if you had a very powerful model, the model could actually just memorize that customer this always gives this, customer this always gives this, and it will struggle in test side because it would have memorized the customer bindings. So we can maybe drop that up front. That is, we don't want that. Df is equal to df dot drop customer xcs is equal to 1. So does it make sense why we are dropping the customer item?
Yeah, understood. But I'm getting a passing error for this when I'm trying to read in the pandas, this CSV file Simons. It's giving me error
Uh,
tokenomic meta CLR expected 1 fields in 941.
for reading this file, the CSV one, or are you reading the XLS one?
No, the CSV file.
So you're doing the exact same thing, but you're receiving an error.
Yes, exactly.
Can you share your screen? Do you have the permissions?
I don't think so. No, I don't have.
Okay, just a sec. Yeah, try now.
Okay. Is my screen visible?
Mm-hmm.
So I got this error.
Okay, wait. GitHub. Am I using the same thing? Yes. Read underscore CSV HTTPS github.com. This is this. Mm, Wait, did you go to the raw file or not? I don't think this is the raw file. Go to the GitHub repo. Maybe just paste down this URL.
Yes.
Yeah. So click on
Okay.
that.
Yeah, I got this one only.
No, yeah, that's the thing. You don't copy this link. You go to the raw file. So you click on that. When you copy this file, you also get the website metadata and things like that. So you'll see something called raw on the right side of the page,
Let's
extreme
keep
right.
opening this.
Yeah, raw. No, it's written there, raw, next to copy. So in the line where it says preview, yeah, raw.
Right.
So you click on that. Yeah, this is the file. This doesn't
Okay.
contain any metadata.
Okay.
So try now.
Okay.
Correct.
Got it.
Okay, so let's proceed. So we have the data. We don't need the customer ID. We have the spending card and coupon. We have separated the Y and X part, and we've also shuffled the data prior to splitting it. So let's now just train a regressor. We call model.fit. Model.fit expects X train and Y train. For some reason, I'm not getting code highlighting today. Maybe restart this. Still no help. So X, Y sample weight. So X is X train, Y is Y train. And once we fit that, we can print model dot score. And say, or maybe just this part first. Yeah, so we have a trained model now. So we can make predictions. So let us say we have pred underscore train is equal to call model dot predict, and then you say X train. So if we print this, we receive the class assignments. But because we want to work with maybe confusion matrices and different thresholds, we would use something called pred proba. Okay, it's either predict proba or pred proba. I'm not quite sure. So let's try pred proba. No. So predict proba. Yeah. So maybe replace this with proba train, and then yeah, we get this. So its shape is 80 cross 2, and every value, the first one is the probability of class 0, the second one is a probability of class 1, and all of them will sum to 1. So if we try this sum xc is equal to 1, everything sums up to 1. So we can either only work with maybe class 1 or like that. Now let us say I asked you to get the prediction on this one. Oh, these are not. Yeah, so let us say I asked you to get the prediction on this one. How would you do that? Any thoughts?
Can you repeat the question?
Ankur, your voice is actually still breaking. I can't make anything out. Can you write it in the chat? Are you using a headphone or something? Maybe that's the reason.
Yeah, I'm using a headphone, but I don't have permission for chat.
For chat?
Yeah, I don't have permission to write in chat.
Okay. So you don't have permission to write in chat. Can present meeting chat is on. Okay. So I was saying in this case, um, if we think about it, we don't actually even need a threshold because I have sort of the values for both. I can do an argmax. And argmax says if this is greater, I'll predict 0. If this is greater, I'll predict 1. If we only work with class 1 labels, then we can use a threshold that is above 50, below 50, or things like that. This essentially assumes, I mean, say, let's say 0.5 or something. A threshold is meaningless here. So if we do this, what we can do is, because we know the output is 80 cross 2, we only need the first column. So we say, give me all the rows and give me the first column. So let us try again. And we get these. So the first one is 0.55, 0.72, zero 0.4, and so on. Now, to get from probability to predictions, you can either use, as you studied in class, that function called binarize from sklearn, or you can just use this thing. That is, you have the probability and you'll say, from probability, I want to index. I mean, let me just do like this. For example, we have probability train and I ask 0.5 is greater than this. This returns an array the same size as probability of train, but Boolean. If you use this thing as a mask, okay, on proba train, it will extract out the values basically. Another thing that you can do is you can convert this to an integer. And in an integer, true becomes 1, false becomes 0. So if, as we did it last time, so let's say we do this and then we say as type integer, we again get the same thing. Okay, so this is the same as binarizing, and this 0.5 is your threshold. So if we change it to 0.25, we get other values. Everything clear up to this point? So we have probabilities, we have predictions. In fact, we can also create a function out of it. Predict, give me probabilities and a threshold, and I will return probability greater or equal to threshold as type integer. So if we try this, predict, okay, works. So now let's go to this part to create a confusion matrix. So creating a confusion matrix has two parts. One is we can either do it ourselves or the other one is sklearn. So let's try sklearn first. So we have the confusion matrix here. It expects y true, y prediction, and we could supply, let's say, labels or sample weights and so on. So it needs y true and y prediction. So let us say we have from sklearn dot matrix import confusion matrix. The confusion matrix expects y true and y pred, right? It expects y true, y pred, yeah. So for y true, let us give it y underscore train, and for y pred, we'll call predict on robot train, correct? So missing threshold. Yeah, so we have the confusion matrix 40, 70, 70, and 16. So can we compute this ourselves and create a confusion matrix ourselves just for better understanding? Can you try that? We just have to individually compute the four coordinates, true, positive, true, negative, and so on, then come up with a matrix. Let's see if the two match. So Ankur, have you reached this point? Confusion matrix?
Uh, yeah, but I know this one actually, so I will stop doing it in between. But yeah,
Okay.
I will just listen more today. Actually, I have a headache
Mhm.
kind of.
Okay. So let's define cal confusion matrix ourselves. What do we need? We need y true and we need y pred. So how do we do it? So we need four things, I believe. So we have true positive, true negative, false positive, and false negative. We set everything to 0. Then what we can do is we can just maybe iterate over y true and y pred and just simply update them. One for loop should do it. So for let us say y true comma y pred in zip, the way you iterate over two things at a time is using zip. So we say iterate over y true, iterate over y pred, and if y true is equal to, let us say, 0, then we are in the negative case, else we are in the positive case, right? So within the negative case, if y true is the same as y prediction, then we'll say that a true negative plus equals 1, correct? Else we'll say a false negative plus equals 1. In this case, we'll say if y true is equal to y prediction, it's a true positive and we will update that by 1. Else it is a false positive and we will update that by 1. In the end, we just have to create a matrix that is say conf mat is equal to np dot um, array, and we have four values. And I think the first one is true positive, and then we have on this side true prediction for a false positive, I believe. Confusion matrix. Okay, TPFP, FNTN. So TPFP, a false positive and a true negative. So we have these things, and you return conf mat. So let's see if we calculate the same thing. So we have calculate confusion matrix. We give it y underscore train. We gave it predictions over robot train with threshold set to 0.5, and let us see what do we get. Um, Field elements must be two or three tuples got zero. What do you mean? Oh, wait. Mm, Something's wrong. So we gave it y plane and we gave it the predictions over this. We set everything to zero initially. We said iterate over y true and y pred. If y true is zero and then y true and y pred happen to be the same, then true negative becomes plus equal to 1. Otherwise, false negative becomes plus equals 1. Oh, wait. This part should be outside the loop. It's the transpose of that or no? No. So what have we done wrong? If y true is 0 and both of you are the same, then you are a true negative. Otherwise, you are a false. No, are you a false negative? Y true is 0, you have been predicted 1, so you are a false positive. And in this case, both of you are 1, and that is a true positive. So if you were supposed to be 1, but you are not 1, so you are a false negative, and then we're missing something. TPTN, FPFN, TN, FP, TPFN. Okay, TPFPF, N, and TN. So these are on the opposite sides. Why? In the confusion matrix, does it print 1 first or 0 first? I think maybe this thing, the um, confusion matrix from sklearn is using label 0 for true positives and label 1 for true negatives. And we are doing it in the opposite fashion. Otherwise, it's the same, I believe. 17.7, 17.7, but 40.16 is the opposite side. Can anyone figure it out? Those that appear at least once used for sorted order. Normalize. Does anyone have any confusion in this part? Does it look correct?
That seems okay actually.
Hmm?
It seems okay.
Yeah, I think it's just the transpose of this, but the transpose would flip these two. It would keep the diagonal there. So imagine if you use class 0 as a positive class, then that would show up here and this would show up here. Would everything else remains the same? Then shouldn't these two also change? If this is 0 class, then 17 should show up here, right? Y true is 0, Y true is same as Y predicted, then I am this. And in this case, probability greater or equal to threshold as type integer. Let us confirm if this is working correctly. So 0.557.400, yeah, this is working correctly. So moving on, let us try to visualize the confusion matrix. So one way to do it is as such, I mean, you can just print it like this. A better way to do it is to use a heat map, especially when you have lots of classes. You don't, I mean, this can grow. Let us say you had 10 classes or maybe 6 classes. This would be a 6 by 6 matrix, and then you cannot figure out which is which when you have lots of numbers on the screen. So you use import seaborn as sns dot set, and we also need matplotlib. So we have import matplotlib dot pyplot as plt. So we say sns dot heat map, and maybe we can give it this thing. Okay, so we see this, and I think we can say annotate equal to true. Was it? So we have data center and not is equal to none. What was I supposed to pass? If true, write the data value in each cell in an array like thing. So what did I pass? Annotate. Seaborn heat map.
Is it expecting a node is equal to something instead of annotate?
No, I mean, if you look at this, I think you can just pass and not equal to true, and it
Yeah,
should
yeah,
pick
yeah.
the
So
values from
not
this.
you
Oh, I wrote
specified
the
the
full thing.
variable as annotate. Yeah.
Okay, okay. Yeah, so we get these values 40, 16, 17, and 7. And the color indicates how much you have. You have a legend here. You can also change this part using CMap. So let us say we give it, oh, what is, I think, let us say reds. So this is one way to do it. If you have a diverging thing, let us say you had two values.
Can we also have a double annotation in which we can also show that this is true positive, this is negative?
You mean
Like
replacing
for
this
the
0
four
with
values.
TP?
Yes, yes, yes.
Yeah, I think we can do that. It is up to us. So if you go down here, you can see you can simply pass the labels, replace the labels with that. Just a minute. Mhm. I think there's a keyword for that where you pass in the labels. Annotation keywords. The dictionary of key comma value mappings optional, but will it be for this part? Let's try it. Uh, 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 uh. Change X and Y labels of SNS heat map. Yeah, but we don't actually need these. We want it to print true positive, true negative. So actually, the heat map doesn't expect there to be just 4 columns. I believe that's the case, why it's not giving it that. For example, in their case, they have months from this to this and this to this. So in this case, they would expect that to happen. For this to happen, I think we have to ourselves supply those things. That is, we can relabel this to be this in our confusion matrix. Let us maybe try that. I think this will work.
Actually, I was thinking that from that sklearn confusion matrix itself, we can pass these values so that we can confirm if which one is the true positive and which one is the true negative kind of thing. Label
So
changing
for
would
example,
definitely
in this part,
with X label and
in
Y
this
label
part,
kind of
huh?
thing.
You mean in
Yeah,
this part?
from confusing matrix that we are creating with C1 underscore max that we created, can we have some kind of labels from where it says like pass it to C1 and then it shows up in the heat map.
I think if I pass labels here, it would actually show me that this is, for example, if I replace 0 with, for example, dog and 1 with cat, I mean, it will say dog, dog, cat, cat. I mean, something like that. I don't think it will say true, positive, true, negative. It will replace 0 and 1 with the labels that I specify. So I think if I want to specify true, positive, true, negative, I can do something like this. That is, if I have the confusion matrix, that is, let us say conf mat. Yeah, so if I convert this into a maybe a pandas data frame or something, and but then what will I call the rows? That's an issue. Hmm. Let's check. Yeah. Yeah, I don't think it says that. So let's see if sklearn has its own confusion matrix visualization. Maybe then. Yeah, even then it says true label, predicted label, and then these values. It doesn't print like that. Okay.
Okay. Okay.
Yeah, so let us remove this part. Annotation is correct. We have these values as well. So we have this. Now we go to ROC. Now for ROC, again, we have a function from sklearn. So from sklearn dot metrics import ROC score, I believe. Computes the ROC, and this thing computes area under ROC. Yeah. So we need ROC curve. So what does the ROC curve take? Again, it takes the y true. This times it takes y score. So in y score, it expects that I pass the probability of the true class. So if my true class is 1, then I should pass the probability of being class 1 rather than being class 0. And it even asks me that who is your positive label in this case. So sample weight, no need, drop intermediate, no need. So for example, we have this thing, true labels. If labels are not either -1, 1, 0, 1, then positive label should be explicitly given. In this case, it expects the positive label to be the second label, okay, as I said. Can either be probability estimates of the positive class or confidence values or something like that. We can supply this thing, and obviously it returns three things. One is the false positive rate, the true positive rate, and the threshold that it used. So let us try that. So we have ROC curve. So we have y true, y score, and I don't think there was anything else, right? Y true, y score, positive is by default the second one. So we can part, let us say y underscore test. And here we'll once again say predict y underscore test. And in fact, we can do y proba. Let us say model dot predict proba y underscore test, and these are my proba test. What happened? Your data should be so y underscore test looks correct. X underscore test. Yeah, so we have the probability, we have, you were saying something?
it's okay.
Hmm. So we get three things. We get the false positive rate, true positive rate, and the thresholds that were used for each one. So we don't need this anymore. We don't need this anymore. We don't need this anymore. So we have FPR, TPR thresholds. Why should be 1D got 2D? Oh, so in this case, it expects all columns first row. So we have these. Let us print the FPR. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And similarly, we have TPR, so on. And what thresholds did it use? 1.7, 0.7, 0.6, 0.5, 0.4. So wait, how can you use 1.75 as a threshold? Does it expect raw values as well? Decreasing thresholds on the decision function used to compute this and this. Threshold 0 represents no instances. Okay, essentially anything above 1. Okay. So it drops it down like this. I don't think it says how it decides the thresholds. Since the thresholds are sorted from low, an arbitrary threshold is this. Yeah, so one way to drop the threshold is to, do it systematically. That is, go from 1 to 0.8 to zero point 0.6 and so on. The more granularity you have, the more fine grained your ROC curve would be. Yeah. Is that clear? That is, you have that ROC curve. If you have few points, you will have a very jagged ROC curve. The more thresholds you have, you will obviously take longer to get the curve, but it will be a better representation of the true thing. So it is using 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another way to compute the threshold is actually they go from point to point. That is, at this point, how many are done, at this point, how many are done, at this point, how many are done, and then the thresholds are decided. So since we have these, um, one way to compute the area is to simply go for each true positive rate, and because it will essentially form a rectangle in this case, right? Because it's not a smooth curve. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let me tell you what I mean. So let us say we do plt dot plot. We give it true positive, false positive. Yeah. So I was saying we will get these jagged lines. And in fact, we can at some point also do it rectangularly. So from one point to the next point, it is just the rectangular area. So we can also compute it that way, or we can just use the ROC function, which can interpolate. So it computes area under this thing. This implementation can be used for binary, multi-class, and obviously other things as well. So we had ROC curve. We can also use ROC AUC score. So let's actually do one thing. Let's plot all of the FPR, TPR points and see what it looks like. So plt.figure fixed size is, let us say, 8 by 8. And we can say plt.plot, give me the TPR, give me the FPR. I want to use the marker this thing, and let us see. We get something like this. Everything seems to be below 0.5. There was another function.
Your voice is not coming. Hello?
My, yeah, hello.
Yeah, yeah, it's coming now.
Okay. So I was saying this doesn't seem correct to me. Everything seems to be below point 0.5 line. Should have been the opposite way. The true positive rate starts with 0. False positive is also 0. Why are both of them 0 simultaneously? If my true positive is 0, shouldn't the other one be max? It says 0. I should have 75% at least. But my ROC curve is on the other side. So why is that? So in this case, if I supply positive to be 1, ROC curve positive label, does it change? No change. Oh, we have plotted FPR first. Yeah, now it looks correct. So there is actually a function to plot a line in matplotlib rather than using linspace. So it's only for horizontal vertical. Okay. Okay. Yeah, or something like that. So in this case, for example, if we have to choose which ROC is the best one, a better ROC is where the height is greater than this distance. Okay, the height essentially says my true positive rate, and this is the false positive rate. I want the true positive to be high and the false positive to be low. So if we come to this point, for example, here, we if we compare this point and this point, then this is the better point, obviously, because it has a lower false positive rate. Now, if I drop down a little bit, in this case, for example, here, I have almost 0.75, greater than 0.75 true positive rate and very low this thing, false positive rate. So this is essentially the accuracy that we were receiving earlier. That is, it is probably using threshold closer to this. So our zero point 0.5 threshold actually lies here. And this point also gives us the same results because we are computing it between these two thresholds. And it seems that a threshold between this thing, zero point 0.1 and almost 0.66, results in the same classification. That is the boundary. In this case, if you shift anywhere between this, there is not much of a change. So you have a leeway in this case. Is that clear?
Yes, it's clear.
Yeah. So we have done this part as well. Let's move on to AUC ROC is just the same thing, as I said. You can just call it over that thing. Another way to do it is, for example, you have this value, this value, this value, this value, four corners. You add this part, then you add this part. And in this case, it is a little bit, I mean, for example, connecting it directly, you can also do it a step function, and then you can approximate rectangularly as well. If you do not want to use the library, if you use the library, of course, it can compute the exact areas. So if we move on to linear regression, in class you studied something called general. At my time, they used to call it polynomial regression. In polynomial regression, essentially what happens, for example, in linear regression, you had x, y, z, you had three columns, and you have to predict a class. Okay, so you were trying to learn a function which says a times x plus b times y plus c times z gives me the class. So I have to learn a, b, and c. So the problem in those days was, you decide the model upfront that my model will be a linear model. I have no control over that. A linear model says I have a linear combination of these guys. So since I'm only learning A, B, C, I am not learning the combinations of X, Y, and Z. I have to do an additional pre-processing step, which is known as feature engineering. Feature engineering says you look at the features, and as a developer, you have to decide, maybe the product of X and Y makes more sense than using X alone. Maybe the square of X makes more sense than doing this and this. So this actually was the main part of your, I mean, machine learning in those days. So before deep learning came into picture, this would take the most amount of time, feature engineering, because maybe cleaning as well. So if you have a very messed up data set, you have to clean it first. Once you clean it, because you see, fitting the model doesn't take any time. You just write four lines of code and you have the model, and it's pretty much deterministic. There is no fine tuning, there are no hyperparameters. This is the main thing. So if you went to Kaggle in those days, everything was about this: who can develop the best features so that the model can work it out. So developing the best features is simple as that. That is, you can maybe take x square, you can take x, y, x, z, and things like that. You can, of course, they were also, I think, sklearn also has something known as polynomial regression. So in polynomial regression, what it used to do is, you give it x, y, and z, and you will give it a degree. That is, up to this degree, I am okay. So let us say you give it degree 2, it will itself generate x square, y square, z square, x, y, z, and similarly zx, and so on. If you gave it a degree 3, it would go on further. That is xxx, and everything up to this point, and those additional points as well. So I think it still has that, but it obviously takes a lot more time. Polynomial features, right? Yeah, so this was there back in my day as well. So does it make sense? This is just a feature engineering step, nothing fancy.
Got it.
Yeah. So I think that's it for today. Any questions?
No, sir.
Yeah, I just have a query like this Kaggle thing you mentioned. I keep getting this. What is it exactly?
I did not understand anything.
Uh,
Can
Kaggle,
you, I mean, share your screen and maybe type it out on the screen if you can't write it in the chat.
is-
Okay, Kaggle. Yeah, so Kaggle was a platform. It still is a platform for machine learning competitions. Let me share the screen. Yeah, just a minute. So Kaggle really took off actually. Earlier days, it was just for machine learning competition. So if you go here, people post lots of data sets. For example, you have this penguin data set. I mean, I in fact got the iris data set from this data set. Remember, we used iris in last class, iris flower data set. So I got it from here.
Yes.
So they have lots of data sets and they regularly also post competitions. And some of the competitions, I mean, they are posted by big tech companies nowadays. For example, Google, this one 200 grand, something like that. Universities post their competitions here. So people enroll in teams and they compete against each other. At the end, their I mean notebooks are also made public, so people learn from each other's code as well. People also post competitions that are meant for learning, that is they don't have a prize money, but people still compete to, I mean, just improve their own skills. Then there are people who will take up data sets and just for the fun of it they will create a notebook, and you can just read other people's work, that is, oh, I could have done this, I could have done that, and things like that. So does that make sense,
Okay.
Ankur? Yeah, it's still quite popular actually, Kaggle. Recently they had a very big data set. I think they got scrolls from the city of Pompeii, which was destroyed in a volcanic eruption. So they had those scrolls. I Let me show you actually. Um, mm, mhm. Yeah, I think this is the one. So they had scrolls like this. So can you see this one? This is a burnt
Yes.
up scroll. You can, yeah, if you even touch it or try to unwrap it, it will just break into ashes. So what they did is the posters of this data set, they first did a 3D scan of these scrolls, and then you use machine learning and stuff like computer vision to unroll this data set virtually. And once you do that, they read the ink of these scrolls and they posted it as a machine learning, I mean, as a competition, that whoever is able to basically take these ink marks and give us a proper text, then we can maybe supply it to people who work on language and they can decipher it. So I think yeah, they have a 200 grand plus.
Oh, great.
So any more
Let's say
questions?
if I have, am I audible?
Yeah, yeah, audible, but I mean still like a robot.
Let's say if I have some kind of brain, maybe lights or pulses, and if I want to identify which variety it is, like there are lots and lots of varieties for all. Let's say pulses. There are, I mean, there are several ones: yellow dal, red dal. I don't know the names actually, but in the rice there are like different varieties like 1409, 1121, and so on. So if we want to, make a scanner kind of thing, so how should we go about it? Like,
Yeah, I actually didn't pick out the entire thing. So what I understood was you was working with something. I did not clearly hear that something. You said there are a lot of ways to do it, and you want to know which path is the correct path. Is that the question?
I will just have it out. Like, there are of pulses or maybe rice,
Uh,
and use a scanner to identify uh, the brain
uh-huh.
of
So I think the most important part in this is actually the data collection. How do you scan this? So is your problem end to end? That is, it is up to you to collect the data as well, or you have the data that someone has taken the pictures.
shared category possibly having
Yeah. So the data is already there.
yeah.
Yeah. Mm-hmm. So, Ankur, I actually have a friend who works in vision. I can give you a
Okay.
rough idea, but I think he can give you a precise answer. I work on graphs, so he works in vision. So can you drop me a message? I'll maybe connect you with him.
Okay. Where should I drop your message? Like,
I mean, you can mail me. Let me give you my mail.
okay.
He's a master student here. There are other PhD students as well. If you, I mean, if it's very necessary, or if you maybe want to proceed in vision later on, it's maybe better to, I mean, have a chat with them and ask them that so and so. So, did you
Okay.
receive the ID? It's in the chat. You can't send
Uh,
messages because you're not a member of the chat. Okay, let me share the screen. It's the same one from GitHub. So, did you get it?
yeah, I got it.
Yeah. So another thing, I mean, Ankur, do you want to do this for learning purposes or is it a competition or something? That is, you just want to have a high score?
No, actually, I work in a nice company, and we wanted to have something this like currently we have people on our role that take out the grade and they usually identify each of the grade. So we wanted to automate this process actually.
Okay. So, I mean, let's say you get a working model, but you don't know how it works. So is that okay?
Yeah, that will be also okay, but I think there is not one yet. We are trying to make it as far as we have researched, and we are getting people from AI and machine learning into our company, and we will start
Mm-hmm.
something on this.
Okay. Yeah. So do drop me a message. I'll get you in touch with them. I think they'll have very good
Sure,
answers for you.
sure. Thank you so much. I will drop you a mail.
Yeah, no issues. So see you all next week.
Thank you for the session.
Yeah, you're welcome.